The Lintel Residence is SAIT's first multidisciplinary collaborative capstone unified through VDC. Virtual design and construction is the management and integration of multiple consultants' models for the construction planning of projects. Essentially, we take these virtual models and make it work. But what is it like trying to make a project work?
It all started with writing an expression of interest and getting to know each other online for the first time.
Our team of skilled and enthusiastic personnel consists of our BIM manager, Taylor Newel, our chief estimator, Santiago Forero, our chief scheduler, Ashkan Arabzadeh,
and myself, Tirzah Van Lindenberg, as the project manager. Together, we are STAT, VDC, Virtual Design and Construction.
This project is a mass timber residence that would replace the Crandall on the SAIT campus.
D4 Design International took the role of the architect, and our civil engineering team took the role of the structural engineering consultant. We found it effective to streamline communication for efficiency. This project was full of real-world challenges, a 12-person team with a multi-headed client. We now understand many contracts along with legalities and jargon. For this project, we used the Construction Management CCDC 5B contract.
We tried using Plannerly to create a semester timeline with certain milestones, but as we progressed, we realized that there are better resources for our organization on a weekly, daily, or monthly basis. That meant Trello quickly took over for both semester-long assignments and work due on any given week. Trello was used for the big picture and organization of work to do, however lacks file sharing and collaboration within assignments. We separated our work within these platforms through the inter-report timelines.
Learning the parameters of different programs allowed us to realize the potential of individual platforms and separate work between ourselves for the best use of our resources.
One thing that we found useful was making a shared calendar between the team. We did this using a simple Google Sheets file. We listed the tasks we would need to finish and the time it would take for each task to be finished. Being time-oriented is a skill that will assist us with keeping track of billable hours.
When we started the project, we assumed what our workflow would be like, but as we continued to work, we actually discovered so many different software packages that aided in this project. We also discovered so many more that we would have loved to use if not for our limited time.
We learned patience while waiting for the design team to finish. We adapted and used our time to research as much as we could about the Brock Commons mass timber residence.
We had no previous knowledge about the mechanical system. The legend only concluded us to so many things and led to more questions than answers. As we analyzed the Brock Commons system, it was apparent that we could not use the same system for our building. We looked closer to home and analyzed the mechanical drawing set of the Aldred Center at SAIT. Color coding the pipes helped us tremendously to realize the connections, and it also hinted us to what each piece of equipment could be.
We learned the value of 3D details, as it requires us to fully understand the construction and apply building science principles and specifications accurately.
Since other groups would be creating their own model and setting their own level of detail, it was hard to figure out how to integrate ourselves into the modeling process while riding right on the heels of D4 and closely anticipating all of their decisions.
We saw the direct effects of a client changing their mind and how this trickles down through to all consultant levels.
Our modeling process ended up being somewhat improvised, but we would have loved to have seen how this project had gone had we had started with a complete set of drawings. Coordinating with other teams became a lot easier with BIM 360 and Desktop Connector. Within our team, we use BIM Track to help create visual context to solve our coordination clashes.
After we analyzed the MEP system of Brock Commons and the Aldred Center, we still didn't know what would best fit our project. We then reached out to a mechanical engineer to decide our options based on the restraints of the design and the climate. We learned about different HVAC systems and discussed how we would go about designing the layout of a mechanical system for each suite. The main heating source for our project is steam. From all the other information we've gathered from our sources, we have proposed a complete mechanical system for our project.
The process for the demolition plan was short-lived.
We had both drawings for the Lintel residence and the Crandall building, so it was really just a game to spot the difference.
When reaching out to industry advisors regarding demolition, we learned plenty. This includes the process of demolition, sanitary considerations, water treatment facilities, you name it.
What we learned from this was it's strictly demolition, but also what to consider in both environmental and safety aspects.
we learned the value of transferring the site, safety, and logistics plan into a 4D visualization.
It was amazing to learn how point clouds can benefit the project process. This became more challenging to use in our project than we thought. These files hold a lot of data, too much for our school computers to manage. However, they hold a lot of exciting potential.
Throughout this process, we consulted specialists and product reps to help understand how we could integrate all of these products into our project. For example, in-floor heating was a great way of understanding why allocating your MEP space and assemblies from an early stage in the project is so crucial.
When analyzing the Brock Commons specifications and drawings, we found a few errors, and this was confusing. We required RFIs and clarifications from our design team. Our architectural design team couldn't provide us with specs fast enough. Managing the changes and the constant updates was time-consuming.
As a team, we learned about the different classes of estimates, how those estimates are created, as well as at which point in the project they are needed. We learned how essential it is for the process of information sharing to be seamless.
The Altus Group Cost Guide and RS Means database were used to create these Class D estimates.
As a team, we were determined to create a detailed Class A estimate for a client. However, we don't have detailed MEP models to price, so our estimates reflect some level of uncertainty. RS Means works exclusively with American dollars from 2011. Programs like Microsoft Excel help to make the tedious conversion simple and automated.
We learned to calculate our prices for inflation. We also learned of the effect on the pandemic on supply and demand, thus escalating the prices of steel and lumber.
When estimating, we had to decide how many teams we would need for each task. This was something that was coordinated between the chief scheduler and the chief estimator. The construction schedule was new and unfamiliar to us. We started out with 12 milestones but narrowed it down to 7. Because we had a mass timber project, we were introduced to climbing formwork. We also learned what task would decide when our crane mobilization would happen. We primarily used start-finish predecessors. This prolonged the construction schedule. We later came to learn that different tasks can happen simultaneously. Later we learned that we should include shop drawings and big payments into our schedule. I was responsible for the 4D scheduling. However, the model that was provided to us by the architectural team still needed some work. We needed to make time-consuming changes so that the 4D animation could progress. An interesting collaboration feature to note was that the way that D4 designed their details for their envelope panels forced the construction to have placed the corner panels at the very end. We reflected this in our 4D animations. CM Builder was very detailed and polished. However, whenever we uploaded an updated model, it would discard all of our past work. Nonetheless, it was a very interesting tool to learn. We edited our CM Builder animation so that the crane grows progressively taller. This makes for more realistic animation.
I can't begin to say how easy Navisworks made our clash detections and adjusting our project. It even worked for highlighting obscure corners of our project that we hadn't even thought to pay attention to.
It was amazing to see how many clashes we found before starting to build. This saved a lot of money up front. It also encouraged coordination between consultants as our 3D models were very easy to navigate. Applying concepts of lean and sustainability were pretty straightforward. However, we believe we could have achieved more points had we incorporated this from the beginning with the design team.
We learned that by providing specs for the water closets and water fixtures, we will be able to qualify for lead points.
It's not difficult to calculate the amount of carbon stored in your building, and it's very important to know. We suggest you try it for yourself. Follow the link in the post below.
We were able to have a federated model that we could upload to Insight for our energy analysis. Reducing the wall-to-window ratio was a good option. However, one could argue that it provides solar gain. We ran a solar analysis and we found out that the southwest part of our tower received little light due to the neighboring residence tower. If we were to complete this process earlier, we could advise and coordinate with the design team to make a more energy efficient solution for our building.
The models and the VR help to create context to present to our consultants, to the owner, to stakeholders, and all parties involved to help give an idea of the finished and ongoing product.
Having fractured my hand pretty badly mid-semester, it didn't turn out to be the semester I'd hoped it'd be. However, it ended even better. Altogether, the synergy that STAT VDC created was exceptional. Through this opportunity, we had the great experience of teamwork with consultants and industry professionals.
This was a wonderful way to conclude our time in the Architectural Technologies program at the Southern Alberta Institute of Technology.
Thank you for watching.